Hello students, this is Shailaja Vibhute. Today let us start 7th chapter, Alternating Current. What is alternating current? It is the current which varies with time. Means with respect to time, current is changing its direction. That current is called alternating current. Then how to represent graphically this AC or alternating current? This is graphical representation of AC. Along x-axis you can take time, along y-axis voltage or current can be taken. Then one cycle of AC means it is the complete variation of AC from 0 to positive maximum, then to negative maximum and back to 0. Means what? Say this is starting point, okay? Then this is called maximum, that too in positive direction, okay? Then it comes to minimum. Then again in negative direction this becomes maximum here, again it comes back to 0. So this is one complete cycle. So this part of the graph usually we consider it as positive and this part we used to consider it as negative. So this is one complete cycle or one complete wave of AC. Okay. Then period of AC means it is a time taken by AC to complete one cycle of its variation. So time taken to complete one wave or one cycle is called time period and it is denoted by the letter capital T. Then related to this AC, let us learn some more words, that is frequency of AC. So what is frequency? It is the number of cycles of variations of AC completed in 1 second. So what is frequency? It is nothing but it is a number of cycles produced in 1 second. It is denoted by the letter F. Now let us see instantaneous value of current. It is the value of AC at given instant of time. So instantaneous value means at given instant of time, what is the value of that alternating current? It is nothing but instantaneous value of current. Then let us see the expression for instantaneous value of alternating current. Expression is I is equal to I naught sin omega t, where I is instantaneous value, I naught is peak value of alternating current, or you can say maximum value of alternating current, and omega is angular frequency. Similarly, we can write expression for instantaneous value of alternating voltage, that is V is equal to V naught sin omega t, where V is instantaneous value, V naught is peak value or maximum value of voltage. So peak value of AC means what? It is the maximum value of alternating current either half cycle of AC. Means both sides you have to take, that is peak value. Maximum value of AC in positive axis as well as in negative axis. So mean value of AC means what? How will you calculate average or mean? Like that only we have to take for mean value. That is, it is mean of all the instantaneous values of alternating current taken over either half cycle. When mean value is calculated for AC, usually we used to get 0. That's why root mean square value is introduced, that is RMS value for AC. It is root mean square we are taking. So it is a square root of the mean of the squares of all the instantaneous values of alternating taken over a complete cycle. So this is RMS value of AC. You can relate or you can write the relation between mean value and peak value. How to write mean value? In general, it is mean value is equal to 2 divided by pi into peak value. This is pi. 2 divided by pi. Here pi is not typed properly, or maybe it is not displaying. 2 divided by pi into peak value. Similarly, if you write for current, mean value is Im is equal to 2 divided by pi into I naught. Okay. So for voltage it is Vm is equal to 2 divided by pi into V naught. So 2 by pi, make it as 2 divided by pi. Now let us see the relation between RMS value and peak value. So in general you can write RMS value is equal to peak value divided by root 2. This is root 2. This is root 2. Okay. Then if you write it for current, it is IRMS is equal to I naught divided by root 2, and for voltage it is VRMS is equal to V naught divided by root 2. So all these you can expect for 1 mark. Write the relation between RMS value and peak value, or write the relation between mean value and peak value, or any definition can be asked, so practice it. Next one is phase of AC. It is the fraction of time period of AC that has elapsed since the current last passed its zero value in the positive direction. Here in this chapter we are using Phasor diagram. So what is this Phasor diagram? It is also called Argand diagram. Phasor diagram is nothing but it is the diagram which represents alternating voltage and alternating current of the same frequency as rotating vectors in the anti-clockwise direction along with proper phase angle between them in the anti-clockwise direction. So when you will draw the Phasor diagram, you will come to know you are representing alternating voltage and alternating current with the help of rotating vectors. So in between those you can make an angle there, that is called phase angle. Okay, so that diagram is called Phasor diagram. Now let us see about circuit elements. The components used in the construction of circuits are called circuit elements. Resistors, inductors and capacitors are circuit elements. In that, now let us take a pure resistive circuit or pure resistor. Pure resistor means what? Or ideal resistor means what? It is a resistor which is free from induction effects. A wire doubled on itself such that currents in the adjacent parts are in opposite direction and multiplying the magnetic field of each other is almost a pure resistor. Means pure resistive circuit, let us take. What is pure resistive circuit? It is a circuit in which an AC source is connected across a pure resistor. Based on this we can derive an expression, that is derive an expression for the instantaneous current in an AC circuit with a pure resistor. Draw the Phasor diagram and mention the phase relation between current and voltage. Show that the same question can be asked like this also. Show that current and voltage are in phase in an AC circuit containing pure resistor. Then how to derive the relation, let us see. Very simple one. First we have to draw circuit diagram. In the circuit diagram you have to show, means you have to draw one resistor, its resistance let it be R, and one AC source you have to draw. Then explain the circuit diagram. In the circuit diagram, R is a resistor connected across an AC source. The alternating potential difference across the resistor is given by V is equal to V naught sin omega t. This is V is equal to V naught sin omega t. Okay. Here V naught is not properly, you cannot see that one properly, so make it as V naught. Okay. So V is equal to V naught sin omega t, where V naught is peak value and omega is angular frequency. Okay, then current in the circuit is given by according to Ohm's law, that is I is equal to V divided by R. So you have to substitute value of V here. What you will get, I is equal to V naught sin omega t divided by R, right as it is. Okay, see, this is V naught. V naught sin omega t divided by R. Then V naught by R, instead of that let us take it as I naught. So even you make it as I is equal to I naught sin omega t. Okay, then where I naught is V naught divided by R, it is known as peak value of current. So in equation 1 it is V is equal to V naught sin omega t, and equation 3 is I is equal to I naught sin omega t. When you compare equation 1 and 3, you can observe that phase difference between current and voltage is 0. You are not getting the term like I naught sin omega t plus pi by 2 minus pi by 2 plus pi minus pi, like that extra term you are not getting. Means what? It means phase difference between current and voltage is 0. Okay, then you can show it with the help of a graph, that is graphical representation waveform. Here if you see the up graph, it is for voltage, then green color graph is for current. Both are in phase. Okay, so here you can show it in phase means what? Here both phase are here pi by 2, here it is pi, here it is 3 pi by 2, here it is 2 pi. So here it is 0. So here what is the phase here? Means phase difference you are not getting here. That's why both are in phase. Both current and voltage are in phase. For that even you can draw a phasor diagram here. Phasor diagram means how you have to draw. You can draw one line. This represents voltage, and one line you can draw that represents current. Both are, means in phasor diagram, since phase difference is 0, we cannot make any angle here. That's why you have to take only straight lines here. So this is phasor diagram for resistive circuit. Okay, now let us take for next one, that is pure inductor. It is a coil of high inductance and negligible resistance. So what is pure inductor? It is nothing but, inductor is nothing but it is a coil. Then pure inductor is, it is a coil having high inductance, but what about the resistance? Negligible resistance. So such inductor we can call it as pure inductor. Then what is pure inductive circuit then? It is a circuit in which an AC source is connected across pure inductor. Here also we can derive one relation, that is derive an expression for the instantaneous current in AC circuit with pure inductor. Draw the phasor diagram and mention the phase relation between current and voltage. The same question can be asked like this. Show that voltage leads the current by pi by 2 or 90 degree in an AC circuit containing a pure inductor. This is a 3-mark question. So now let us see how to derive the expression. For that first you have to draw circuit diagram. So first figure is a circuit diagram, second one is graphical representation, that is waveform, and third one is, that is C, is phasor diagram. At once you draw all the 3. So in circuit diagram, first you concentrate on figure A, that is circuit diagram. So L is the inductance of the inductor connected across AC source. Okay, it is a coil having inductance L. The alternating PD across the inductor is V is equal to V naught sin omega t. Let us name it as equation 1. If you explain the symbols here, V naught is peak value of potential difference and omega is angular frequency. So PD across the inductor is V is equal to V naught sin omega t. If we take, let E be the EMF induced in the coil, means how EMF is induced in 6th chapter. We have learnt this one. When current is passed through a current carrying coil, then around that one we are getting magnetic flux. Due to change in magnetic flux, EMF induces. Correct. So that phenomena we called it as electromagnetic induction. Just similar here, you have taken one coil, correct, having self-inductance L. So when current flows through this coil, then EMF induces. Correct. Let E be the EMF, V be the potential difference. Now let us apply Kirchhoff's rule, that is loop rule. Second law you can apply to the circuit. Then what we will get? We will get V plus E is equal to IR. Actually sigma IR is equal to sigma E. Correct. So here IR written as it is, sigma E is V plus E we have written. But for pure inductor, resistance is 0. So you will get V plus E is equal to 0. But we know one more relation which we have learnt it in 6th chapter, that is E is equal to minus L di by dt. Induced EMF across a coil is E is equal to minus L di by dt. So if we substitute that value in the above equation, we get V plus, in the bracket you substitute value of E, minus L di by dt is equal to 0. That minus L di by dt, if you shift it this side, you will get L di by dt is equal to V. Adjust the terms and write for di is equal to V by L into dt. Let us name it as equation 2. From equation 1 and 2, what is equation 1? V is equal to V naught sin omega t. What is equation 2? di is equal to V by L into dt. Means you substitute the value of V. What is value of V? V naught sin omega t. So what you will get? di is equal to V naught sin omega t divided by L into dt. We want to get total current, so you have to integrate it both sides. Integrating above equation with respect to time, what you will get? Integration of di is equal to integration of V naught sin omega t divided by L into dt. Integration of di is I. Okay. Then V naught divided by L is constant, so you cannot integrate it, write it outside. So V naught by L. Now integration of sin omega t dt you have to take. Integration of sin omega t dt is minus cos omega t divided by omega. If you write this one, what you will get? I is equal to I naught omega L minus cos omega t can be written as sin omega t minus pi by 2. This can be written as I is equal to I naught sin omega t minus pi by 2. Let us name it as equation 3. Where I naught is V naught divided by omega L. It is nothing but it is peak value of current. So what is equation 1? V is equal to V naught sin omega t. What is equation 3? I is equal to I naught sin omega t minus pi by 2. Means pi by 2 extra term you are getting. Means what? By seeing equation 1 and 3, we can conclude that the voltage leads the current by pi by 2 or current lags the voltage by pi by 2. It is shown in even phasor diagram. So phasor diagram is you can see in this phasor diagram this one. Say this is voltage, current we have to draw it in negative axis because minus pi by 2, this is voltage, this is current. Okay, here you are getting minus pi by 2 or minus 90 degree. Okay, this is phasor diagram. Clear? Okay. Then let us see about inductive reactance. In case of pure inductive circuit, the peak value of current is given by I naught is equal to V naught divided by omega L. So this can be written as V naught divided by XL. The quantity omega L is same as that of resistance, and it is called inductive reactance. XL is nothing but it is inductive reactance. So it is denoted by XL. Now what is definition of this inductive reactance then? How will you define resistance? It is opposition offered by the conductor for the flow of current. Just similar to that one, you can write the definition for inductive reactance. Inductive reactance is, it is amount of opposition offered by the inductor to the alternating current flowing through it. Opposition offered by the inductor for the flow of alternating current. It is nothing but inductive reactance. Say if we get a question for 1 mark, mention the expression for inductive reactance and explain the terms. How to write? XL is equal to omega L, but omega is equal to what? 2 pi F. So you can write it as XL is equal to omega L. It is nothing but 2 pi F L, where omega is angular frequency, F is frequency, and L is inductance. Okay? Thank you.